Hi, welcome to our math. Today I'm doing a series of videos on solving systems of equations with Gauss Jordan elimination. Okay, so the first step in doing this is to take your system of equations and write them as a matrix. A matrix basically means we're going to write the equations without the variables. So the first equation becomes 4, 4, 1, 24. Then we have 2, negative 4, 1, 0, and 5, negative 4, negative 5, 12. Matrix means brackets. Augmented matrix means we represent the equal signs with a line. So 4x plus 4y plus z equals 24. Okay, so the goal in this process is to get ones along the diagonal and zeros everywhere else. So oftentimes I'll start right here at the top and I'll pivot on this 4 and use the 4 to zero everything else out. With a second column so beautifully set up with equal but opposite 4s, I'm actually going to pivot on this 4 instead. So what I'm going to do for this, to get this 4 to zero out that 4 through addition or subtraction, I just need to say row 1 plus row 2. To get this 4 to zero out this 4, I'm going to say row 3 minus row 2. All right, so I'm actually going to pull out all my work so you can see exactly what I'm doing. Row 1 is 4, 4, 1, 24. And row 2 is 2, negative 4, 1, 0. And when I add down, I get 6, 0, 2, 24. Because they're all even, before I put this back into my matrix, I am going to quickly divide by 2. So that becomes a 3, 0, 1, 12 instead of these numbers, just to make everything smaller. Okay, so then I have row 3. Row 3 is going to be 5, negative 4, negative 5, 12, and negative row 2. Notice I'm not saying writing a row 2 and subtracting it. I'm actually going to multiply that negative 3 so I can add down. If you try to subtract all 4 numbers, you're probably going to be adding by the end anyway. So a negative of row 2 becomes a negative 2, a positive 4, a negative 1, and a 0. And when I add down here, I get 3, 0, negative 6, 12, and this time I'm going to divide by 3 so that I have a 1, 0, negative 2, and 4 to make my numbers smaller. Okay, so what I'm going to do is I'm going to compile all of these numbers into a new matrix. My first row becomes this 3, 0, 1, 12. My second row stays 2, negative 4, 1, 0. And my last row becomes 1, 0, negative 2, 4. Put it in brackets to make it a matrix, give it a line so it's an augmented matrix, and now I have a new matrix that I can start pivoting on. Okay, so I have this new matrix, and now I'm going to pivot on, well, I'm going to pivot on my 3. So to pivot on my 3, I need to eliminate the 2, so I'm going to say 2 times row 1 minus 3 times row 2. Because if I take 2 times 3, I get 6. If I take negative 3 times 2, I get negative 6, and then they will add to 0. For this one, I'm going to say row 1 minus 3 row 3's. 3 minus 3 times 1 is 0. Okay, so let's see if this all works out. 2 times row 1 is 6, 0, 2, 24. Negative 3 times row 2 is negative 6, 12, negative 3, 0. When I add down, I get 0, 12, negative 1, 24. Okay, then I'm going to do row 1, which is 3, 0, 1, 12. I'm going to do negative 3 times row 3, so negative 3, 0, 6, negative 12. I'm going to add down 0, 0, 7. Ha ha ha. This is a beautiful one. 0, 0, 1, 0. Okay, so I'm actually going to move this up to the top. My first row is going to stay the same. My second row is going to be the 0, 12, negative 1, 24. My last row is going to become this 0, 0, 1, 0. I'm going to write all of that up here so we can see our initial. I'm going to put an arrow so that if someone looked at my notes, they would know exactly what I did. Again, my first row is this, what I pivoted on, 3, 0, 1, 12. My second row got calculated to be 0, 12, negative 1, 24. And my last row got calculated to be 0, 0, 1, 0. All right, so row 1 minus row 3, row 2 plus row 3. All that's going to do is zero those numbers out. I'm actually going to save a little time and just say, hey, that becomes a 0 and that becomes a 0, because that 0 won't affect. So my new rules is row 1 divided by 3 and row 2 divided by 12. I don't do this kind of thing often. I'm only doing it now because these problems do get long, and rewriting all of that just to say the 1 and negative 1 become 0 seems like more work than we need to do. All right, 1, 0, 0, 4, 0, 1, 0, 2, 0, 0, 1, 0. We have an answer. This translates to x equals 4, y equals 2, z equals 0. I want to check my work with my original. I want to check that 4 times 4 plus 4 times 2 equals 24. Notice I'm not writing the zeros. That doesn't really matter. That's 16 plus 8. I want to check that 2 times 4 minus 4 times 2 is equal to 0. That's 8 minus 8. And I want to check that 5 times 4 minus 4 times 2 is equal to 12. That's 20 minus 8. That all works. So my answer becomes the ordered pair 4, 2, 0. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.